further ado, John, if you're ready, and if the equipment is ready, because this has gotten to be such a technical expertise these days, the way we're going to work it is we're going to start off, Barry is going to do his presentation first. There's going to be a pause in the broadcast while we readjust the cameras and everything else. Waleed is going to be on a little later in the day. Where'd Norm go? Norm's not here.
Norm's hiding.
Okay. Well, Norm is going to do, I think, a short talk. I think Jim is going to introduce us to some of the cartridges, talk about some of the RAM discs that you have, or the SAMS discs, rather.
Well, no. I'll talk about my tribulations with the SAMS.
Okay. Well, at any rate, you're going to be up in a little while, and you have to do come up here. Waleed has also got his equipment all set up. John's got the technical stuff over here. We have a microphone that only has one TI-99 battery in it, so we're going to turn it on and off between presentations so that the people at home can actually hear what's going on. We have the limitations that always, Vic, I'm sorry, I forgot to mention you're going to do a demo as well. And are you going to do it up here, or are you going to do it down there?
I have to do it up there.
Up here. Okay, fine. So we don't have to move your equipment around. All right, it's fine. So now we haven't got everybody in the room yet. It's going to be in the room by the end of the day. People will walk in and out. This door, these doors, I think, are locked. The only door that's actually open is that one in the back. If you have any questions, we'll move some of the chairs up here, so that when we pan the camera around, it looks like there's more people here than there actually are. This is the fewest people we've ever had, ever. Anybody who's been here before will tell you that generally there's, in the past few years, we've had 20, 25, 30 people here. And this is the smallest crowd that's ever been here. But it's a COVID year. Hopefully next year things will get back to normal again. We'll have more presenters, we'll have more demos, we'll have more people here to do.
And it's the 40th year.
What's that?
And it's the 40th.
And it's the 40th year. It's a big 4-0. So, provided I make it to 4-0, I just turned 77, so you never know. That's about it. So, again, don't forget, if you're parked downstairs in the basement, that is closed at 6 p.m. and they bring the gates down. They don't open them again until noon tomorrow morning. Now, if you want to just have a safe, free place to park your car all night, and you're not doing anything until noon tomorrow, it's a great place. Just leave your car there. They're not going to ticket you, but you're not going to have access to it until noon tomorrow. You can drive out then. I've done that actually in the past. It works rather well. But that's when the infamous pub crawl went till 4 or 5 o'clock in the morning, and then we would go over to Burger King and crash out on the tables. But we don't do that much anymore. Oh, and by the way, Burger King is gone now too, so we can't do it. It was the last free place to park in the whole damn city of Evanston. So, does anybody have any questions before we begin this? Is there anybody? Jim, did you? Oh, no, you just put it back. Okay. Are we ready then? John?
Do you want to bring chairs up here closer now?
What's that?
Or you want to bring chairs up here?
Yeah, we can bring some chairs up, but what we'll do is we're going to make a pause in the broadcast, right? We're going to make a pause in the broadcast, and then we will rearrange some of the chairs, so we don't have to do it right now. So we'll have.
Have them turn the mic on. Let's go.
I'm going to talk first.
Puzzle with and
Need the mic first?
no.
We're going to use this mic. All right. I'm going to be facing. Okay. We got this set up, and we have people. Now you can't put any chairs between the camera and Barry. And we have a.
You don't need them, I think.
Yeah, I think you're right. I'll just bring one more just in the second row.
Only obsessive a little.
Only a little.
As I said to somebody else yesterday, I don't think there's anybody in my entire life that isn't somewhere on the spectrum.
About here? About here? And all set? Count it down. Tell me when we're live. Oh, we're live. Well, if you waited this long, we hope that you're still with us. Originally, the broadcast time was stated as being a couple of hours earlier, but as all things TI, we've had some technical glitches. But anyway, welcome to the 39th edition of the Chicago TI International World Fair. We have a COVID year, as everyone at home, I'm sure, understands. Things have changed a lot. Last year we were a total virtual show. This year we're a live show once again, a live fair, and we're all glad to be here. We wish more of our friends were able to be here, but the people from Europe, unfortunately, are not able to get to this country at the moment. Many of our friends from Canada are not able to get here, but we do have a number of people who have come, and many of them have come before. Hopefully many more will come next year when we have our 40th Chicago TI International World Fair. In the meanwhile, my name is Hal Shanfield. I'm the fair chairman. We have a broadcast that's being engineered right now by my son John Shanfield. Our president Vic Stirrup is over here. The king from our monthly show, Jim Mazurek, Ken Griffith, John, and I, and others that come and do the monthly show are all here today. We have a number of people who have made some presentations. Now the show is going to be just a little bit different than it usually is. Instead of running continuously, what we're going to do, because we have people scattered around and using equipment in different parts of the room, we're going to pause the broadcast and then we're going to do some technical setup, and we'll probably have some glitches. God knows it's a TI show. These are TI demos. You know what that means. Nothing's ever perfect in a TI demo. That's how you know that it's actually a TI demo. At any rate, we will then be pausing the broadcast and then setting up and then resuming the broadcast. So sort of just stay tuned, have a cup of coffee, do whatever you do in the meantime. I promise that there'll only be a short intermission each time, but we will try to make it as short as possible. We'll try to correct any technical imperfections that we're having before you see them. So that's about it for right now. Here we are in downtown, lovely downtown Evanston, Illinois, and welcome to the show. We will be monitoring the chat, by the way, so if there are any questions that you ask, if you put them in the chat function, we'll try and answer them as we go along. We like your comments, we like your questions. If we have questions for the individual presenters, we will try to ask those questions of the presenters while they're doing or as they complete their demonstration, and then perhaps they can address those questions individually. So, John, are we ready? Now I guess we're going to take a short intermission while we set up. Our first presenter is going to be Barry Miller, and we'll let Barry tell you what he's going to talk about. So, stay tuned. Are we up? No, we're not going to keep going, John. We're going to take an intermission. Did you hear what I just said?
We have a commercial break.
Okay.
It's gotta
Got
go.
my ear, headphones on. So are we ready with Barry?
Yes.
Okay, that was a very short intermission.
Ready to go, Barry?
All right, can you hear me on the microphone there, John?
Yeah, we turned down the microphone.
I just started.
Oh, you got it out. Good.
Can you hear me, John? Testing
1,
1,
2,
2,
3.
3.
Testing 1, 2, 3. Testing 1, 2, 3. Can you hear me? Okay. All right. Today I was going to talk about the Geneva 9640, which is the upgrade of the TI-99 4A made back in the early 80s. back about a year ago, Tim, which some people may know as Insane Multitasker on Atari Age, he and I started working to update the version of MDOS to the current version that it is now, to add extra support to some of the peripherals. Before I go any further, though, I will say that we have at least one gentleman here that's looking for a Geneve 9640. So if there's anybody that's watching this video on the call and has a Geneve sitting in the corner they're no longer using and might want to put it up out there for somebody that might use it, please post a note there for John to pick it up so he can pass along some information. Well, Tim and I started working with the Geneve 9640, updating MDOS, like I said, about a year ago. I had, the previous year before that, had worked on integrating what I call the messaging system that Matt had made for the TIPI and the PI combination for the TI-99 4A. I had developed it to the point where the messaging system, so you could do telnet connections, were possible then from the MDOS side of things on the Geneve. After working through after building up enough interest with Tim, he picked up a TIPI, he got very interested in bringing the TIPI support to the Geneve. We worked on getting the existing DSR that Tim had provided, or that Matt had provided on GitHub, got that core piece as a assembly source file there that was part of MDOS, and then Tim, over the next 4 months, took time and integrated those pieces that were needed to converse with the rest of MDOS, and then we had, within 2 months' time, we had MDOS talking to the TIPI for file saving, loading files, and loading programs. We worked out all the kinks there so that all the support was there. And I will have to say that Matt's implementation of the TIPI for the Geneve made the development a lot easier. Whereas with the floppy disk controllers and other disk controllers out there that handle the full bitmap imaging for file storage and stuff on the devices, the TIPI, all you do is pass it through the messaging system to the PI, and then Matt's code on the PI side did all the file saving, retrieving, and so forth. So the largest part of the load, which is the most complicated part, Matt had actually already accomplished doing it for the TI-99 4A. So it was just we just needed to do the proper mapping on the Geneve side. And I have to give, I'd say 95% of all the credit for the MDOS work that was done to Tim. So don't think it was me behind it. It was Tim behind it that accomplished everything, majority of everything that was done there. After the TIPI support was working, then we started adding other capabilities. There was a few things with the SCSI code that needed to be resolved, that needed to be fixed. And then Chris Snyder had released an IDE board for the 4A, and Tim had already developed some code for the MDOS to work with the IDE. Tim got that interface as well. So now we have an MDOS that supports the TIPI-PI combination, and on my work system at home, I've got 128 gigabytes of storage for the Geneve with a PI with a 128 gig SD card. It's got a SCSI drive, it supports the MFM hard drives, and it supports the IDE drives, as well as all the floppy controllers out there. So basically any hardware that's out there now, the Geneve pretty much supports it.
Didn't you have to remove support for the SASE controller, the original MyArc hard disk controller, to do that though, if I remember correctly?
We removed the MyArc, we removed any pieces of the MyArc personality card.
Yeah, that's SASE.
Okay, all right. We removed those pieces there because most of that had been removed, but we saw a few fragments there that were overlooked. I don't think the later versions of MDOS was even supporting it anyway. But cleaning up the code, we just removed some of those potential gotchas that could be there.
Right. The only reason I mentioned it was there's still a half a dozen of us that actually own one of those personality cards, so.
Okay. But yeah, I didn't have one, Tim didn't have one, so testing out what would or would not work was there. And I will have to say that anybody that does have a Geneve, get you a Tippy and a Pi. There's so much more capability that you can do now that didn't exist. That's the best upgrade a 4A user or a Geneve user can make to their system. But we went on and added support for all those controller cards. And I've got a little demonstration right here. Back in the 90s, Mike Riccio started work, I guess contracted with MyArc for a program called Geme, G-E-M-E. I played with the code, some got it to a little bit larger, another step forward, but it's not anywhere near as where it needs to be. But it was going to be a Windows manager for the Geneve. Now, it's not to that point, but what I was able to do, though, was create some slides with the program to talk about some of the capabilities of the Geneve. And what I want to do is describe what all was released back in April of this year for the MDOS version 7.30. This particular color here doesn't do well, I guess, on this larger screen, but we added the support, like I said, for the IDE controller, which supports up to 8 IDE drives on the system. We added the Tippy support for DSK capability, which means DSK 0, 1, 2, 3, and 4. That's are the same drive letters that's available there on the 4A. We added the support for Pi, which includes where you can load the pi.config, pi.reboot, and several, I think, pi.pdf, so you can print to a file called pi.pdf, and your file will be generated as a PDF on the Pi, so you can go and print it to your printer. The URL mapping, so you can load files off the internet from MDOS or the GPL mode, just like you can on the 4A. And then what's also been embedded on the MDOS side of things is a telnet client. So now you can connect to your Pi directly if you need to make changes on your Pi, or you can connect to another website with the telnet client. So if you want to connect to the Heatwave BBS, you can connect to the Heatwave BBS right from the MDOS prompt. You connect to the Fusion BBS prompt, or you can connect to the Keep that Greg McGill's got as well. The Horizon RAM disk support was added. On my particular system here right now, I've got a MyArc HFDC, and I've got a DREM, that's D-R-E-M. If you go to the website drem.info, you can find that device, but it will plug into an HFDC, and it will allow you to emulate 2 64 megabyte hard drives on your system. This should work for the 4A, and it works for the Geneve. There's also the capability of that DREM can emulate floppy drives as well. However, that doesn't work 100% of the time on my system, so I just use it for the hard drives. I have no use for the disk floppy access. Like I said, embedded telnet client. There was also released in this massive update we did, the GPL interpreter was updated to version 7.30 to deal with all the changes that took place on the MDOS side of things. ABasic was updated, fixed a couple errors. I'll have to give a lot of credit. He's been deceased for a number of years, but Jim Uzel, I think is how you pronounce his last name. But he made all the updates and bug fixes that took place with Advanced Basic on the Geneve. There was a couple of things we found later on that over the years, and then I updated the manual to include all the updates on it and released it with the package. Tim, aka Insane Multitasker, wrote a program called GenConfig that basically, I'll describe it more in a little bit. There was also PFMsys. PFMsys allows you to, if you have a PFM device on your Geneve, you can embed MDOS into it so that it boots up off of a memory chip on the Geneve itself for quicker booting. instead of booting off of a device. It also required another program for PFM core up that needed to be updated so that you could, because MDOS grew by an extra 8K in this last update, and that's to include all the PI support and the IDE support, so it needed an extra 8K of memory. So in order to fit that, the controlling chip on the PFM system needed to be rewritten, and Tim updated that, as well as then updating exec. The process of adding SCSI support, back, I guess in the 90s, there was a command that was added called SCSI map, SCS map. It allowed you to map a device to a particular drive number so that things would talk, because we were adding a whole lot of different devices. So we have support there for if you have a SCSI hard drive controller, you can have up to 6 SCSI hard drives connected to it, but you're only going to be allowed, I believe it is, to map 3 SCSI devices at one time. You can't, we don't have support, or maybe I'm wrong, but SCSI, I'll take it back. There is. You can map SCSI 1, 2, 3, 4, 5, and 6. So you can pick 6 devices. Now those 6 devices can be SCSI device 1, they could be SCSI device 5. You could pick a Horizon RAM disk. You could pick an IDE drive. You're asking, well, why is a Horizon RAM disk a SCSI device? Tim made an update to the Horizon RAM disk after Jim came out with the 8 megabyte Horizon RAM disk, so that you can partition that Horizon RAM disk up as floppy drive images, or you could format it as a hard drive RAM image, so that basically the Horizon RAM disk behaves as a like a large hard drive. So instead of being limited with a floppy side on 3 subdirectories, now you can have 127 directories on your Horizon RAM disk, and then directories and folders underneath of it.
That capability only works on a Geneve, not on a regular 4A.
Yes, that's correct. It only works on the Geneve. That's not a 4A feature there. That's a benefit of MDOS. Now, we expanded the remap capability. The remap, that was implemented back in the early 90s when we had smaller Horizon RAM disks that were out there, some of the smaller 8-bit and 16-bit Horizon RAM disks, so that it could distinguish and you could be able to use those Horizon RAM disks. And there was other devices that were out there. We had the floppy, you have normal floppy drive 1, 2, and 3. That could be like a TI disk controller. And then the MyArc Core Comp and MyArc HFDC all added the 4th drive to it. So you can remap drive numbers to those. So you can have disk 1 through disk 9 mapped. You can map the Horizon RAM disk. You can map an internal Geneve RAM disk, a Rave RAM disk. I've not actually seen that utilized myself. You could actually map an emulate file that the HFDC had the capability of. And if you wanted to specifically map an HFDC floppy drive, that was separate from the MyArc floppy disk controller. And you had 8 and 16-bit Horizon RAM disk. And I'll step to the next screen. And then we get back to, you still have the Horizon RAM disk for the 800K versions. There's a couple of reservations. The PFM flash disk, which was part of the PFM core system, you could actually have sort of like a permanent ROM, if you want to think of it like that way, a permanent ROM image of files on that PFM that you can store on it. Tim has an idea for creating a secondary PFM flash disk. It's not been implemented at this point in time. And then we also added the addition of TIPI DSK 0, 1, 2, 3, and 4. So if you have on your pi.config, if you've mapped TIPI DSK 3 to a particular folder, then that would map that as a drive number under MDOS. And that would carry over into the GPL interpreter as well. Well, and that color scheme definitely does not work. When the Geneve came out, we wanted to have, or when this latest version of MDOS came out, we wanted to be able to expand the ability to boot off these new devices. So Tim had some code that had been tweaked a little bit for booting SCSI. So I went in and updated the EEPROM code to be able to boot up off of IDE drive. You can boot up off the TIPI drive, you can boot off the HFDC drive, you can boot off the Horizon RAM disk, or you can boot up off a floppy disk. I think it covers all the options there. And they all will have boot tracking so that it will load the auto-exec file off of whatever device it loads from. And that EEPROM version uses the original Geneve Swan that was with the original release of the Geneve. I think it was Tony Nur that released the new screen. However, he patched pieces around, and we were not able to implement the code into his pieces there the way he had implemented it. Now, if anybody has a Geneve and wants to be able to add an IDE drive or a TIPI to it, then you can either go to Arcade Shopper or Bob Carmody, or you can go to the website 9640news.com if you have a burner and you can burn your own EEPROM. But Arcade Shopper or Bob Carmody have we'll send you an EEPROM there for about $7 or $8 that you can plug in your Geneve, and you can boot then off of those new devices that are out there. Now with the Horizon RAM disk, Tim updated that so that there's a program called GenConfig. Now for the 8 megabyte card, you can configure it. There's 2 CRUs that can be configured at either 1400 or 1600. You can configure it as a disk drive. You can configure it as a RAM hard drive that can auto boot, and then the program will actually format that device. So the floppy, it'll format it as a floppy if you have it as one of the options, and as well as the hard drive options. So right now in my system right here, I've got a Horizon 8 RAM disk, courtesy of Jim, that I bought back a couple years ago, that's got 8 megabytes of RAM on it. And that's where most of my MDOS development, because that's the fastest device out there right now for assembling it. To give you an idea, on a MDOS to assemble the complete source code, it's over 100,000 lines of code, and it takes about 10 minutes on a Horizon RAM disk to go through all that assembly. And then Tim also, the GenConfig program also identifies what cards are in the system in your PE box, so that you're fully aware of what's going on there. All right. Now I did want to show a couple things here that's transpired over the years. Or I want to show Tim's GenConfig program here. It tells me what I've got in my system. I've got a MyArc HFDC, the RS-232 card, the Horizon RAM disk. It's got 8 megs of RAM on it. I've got let's see. The RAM disk, there's a RAM disk on it that's configured out to 1600 sectors on it. And then the hard drive is configured out to 31,158 sectors on it. Now I can select to format that if I want to, scan it, I can make a disk bootable, or if I need to, or something happens, I should be able to recover the hard drive image if something were to happen on it. I'm not going to go back in and do anything. I'm not going to reformat my hard drive because I've got everything on it right now. I'm going to hit quit. Another program I'd like to just show you quickly that Fred Cal updated for the Geneve. people may be familiar with DM2K for the TI-99 4A that looks at, that will properly catalog a tippy. Well, he modified it so that it would work on the Geneve. And the G in front of the DM2K is for the Geneve version. So now you can see what the program will look like. Fred Cal in the Netherlands, he wrote this program. Now it's cataloging my tippy drive. I've got somewhere around 4 to 5 gigabytes, I believe, on my tippy drive. Let's see. I can tab back and folder to, so I can look at 2 different drives. If I want to copy files back and forth, I can do that. The other nice feature about this particular program is I can take a hard drive image right here. I can mark all the files here at the root level, and it will copy everything from, I'll hit the A for all, so that's marked all those files. And if I tab back over here, I'm going to select one. I mean, one is backup, I think, of already my hard drive anyway. But now I'm at a path over here, so if I go tab back over to the right side for the hard drive, and if I tell it to hit, if I were to hit C, it's going to automatically start copying all the files from the top level and all the subfolders below over to the tippy. So now I have a very easy way, if I want to copy files from my hard drive to a tippy drive. Now, if I want to make a backup of my tippy drive, which I do periodically, then I've got a Windows map folder on my Windows PC. I go into it, highlight the files, and I drag them to a folder on my Windows computer, so I can make a backup of everything easier instead of going to floppies. This is probably the most reliable system for floppies. If you remember back in the HFDC days, you backed up everything to a 5 1/4 inch or a 3 1/2 inch floppy, and you may take, depending upon the size, how much you had stored, you may require 20, 30, 40 floppy disks. And if one disk went bad, you lost your whole backup. But now you can copy everything here quite easily. The other thing about the tippy is there is no restriction in a folder how many files you can have. I've got a folder, I'm not going to pull it up because it's going to, the Geneve version of DM2K doesn't support a directory listing with 4,000 files. I don't know why it can't handle 4,000 files, but it can't display 4,000 file names on the screen. But you can have, I think upwards of 100,000 files in a folder if you wanted to, that are accessible from the Windows side of the system, but just not accessible on the TI system. So what I've actually done is all those folders are there. All those files are in, I got a bunch of files in one folder because I updated the program called After Hours BBS. So that's a download folder so that people can download files out of that one particular folder. And there was a demo last year when we were just doing the Zoom deal where I demonstrated After Hours, but After Hours BBS program uses a tippy. It works on the Geneve as well as the TI-99 4A. That has now been expanded as of middle of this year. That also gives ANSI capability as well. So if you wanted to run an ANSI bulletin board, just set your Geneve or TI up on it, you could actually do that as well. I'm not able to show it like I wanted to because I cannot get the mapping with the library internet capability here. But one of the things I took, for those of people that are familiar with port for the Geneve that Tim wrote, that Tim provided me the code there for the ANSI's capability of it. And I took the ANSI part of the module there and wrote what was called an XOP driver and embedded that into the operating system embedded as a separate driver for the operating system. So if somebody wants to display something that's ANSI, you can display it quite easily using the driver. Let me take a look at my. Right now, I'm going to tell it there's three. I got 3 files in here. Sample 1, 2, 3. Let me try 3. I think 3 looks better. I can show that ANSI file in text mode or graphics mode. It's going to show up in graphics mode right here. Well, for some reason it didn't. All right, looks like I'm rebooting my Geneve. Something happened there.
It wouldn't be a TI demo.
Yeah, something happened there.
Kazoo came to say hello.
Yeah, this is booting off the Horizon RAM disk right now. A little. I'm not going to put any pressure on somebody. Never mind. The ANSI driver's loaded. Here's the latest version. Make sure I got everything right there. I think I know what happened. Let's try. All right, there we go. Now, all that is. This is going to be the next release of MDOS. Tim's got a couple updates he's doing. There's been some wish lists that people have had for MDOS. After we released 7.30, we've tried to accommodate some of those things. It's more the easier fixes. But I have embedded now with the next release of MDOS, we'll have a Telnet client that is ANSI capable instead of just text-based able. And the type command, you can actually type out a graphic file there to the screen. And this is, that's used to be, this was all part of a separate program, but now it's talking to the ANSI driver that's in MDOS for display on the screen, letting MDOS do it instead of a separate program. So if somebody wanted to do some ANSI display of graphics on the screen, you give it the ANSI line that you want to display in a piece of assembly code, and in 4 lines of code, you can display the ANSI string on the screen. All right, let's see if there's anything else. I don't, John, did we have any questions coming in from?
We have a number of comments, all favorable, very impressive so far. If you are done with the screen, I can turn the lights back.
Okay, all right. Yeah.
So we can see it.
Okay. Now, I will say the MDOS purchase took place in about 92, 93 time frame. I don't remember the exact year, but it was made possible by, I think, well over 100 individuals that contributed to the purchase. So that, I flew up and met with Paul Charlton when we bought the MDOS in, and individuals like Al Beard, Tim, Clint Pulley, Jim Ozel, Mike Maximic, Jeff White. I'm sure there were some other individuals.
Me.
Pardon?
Me.
Okay. There was a large number of people that made various contributions over the years that made all this possible. Even James Schroeder, he worked out a method there for getting all the different Horizon RAM disk capabilities there. So there's a lot of individuals that went toward it. This was no single man effort there. Everybody made various contributions over the years. So it was a miracle that we got this far. And right now there's even an individual that's working on a Geneve 2020.
Jerry Coffey. He was working on the P system thing to make the P system work.
Okay, all right, okay. Now, I don't have a working, I've got stuff on the P system, it's not working, but I'm not a P system person, so I don't know if I'm doing something wrong or if it's, or
I've got to test it again.
yeah, but yeah, it's not doing what I think it should be doing, but I don't know if it's because I'm making a mistake or it's not functional there. But some pieces work, but not what you, if you wanted to write a Hello World test program, I can't do that. I can't get into the system to do that. So,
You need 2020.
what about it?
What is it?
What's the gentleman's?
That would be Eric Olson.
Yeah, Eric Olson, he's working on Geneva 2020. I think he's going to be through with development of that hardware next week. Not trying to put some pressure on him. No.
I would say next week in 3 years.
Yeah, I'm just teasing. It's the Geneva 2020.
Hard job.
He's got a massive project here of a lot of major steps need to be accomplished to get that, but he is working on such a project. And if it comes to fruition there, I mean, I've got no qualms on him trying to adopt the MDOS support out there into it. And I should add that the 9640news.com website has a lot of links to the GitHub source code to the various things. We haven't released the source code for the latest version of MDOS because not that I think anybody's going to go out there and start trying to update it, but we want to make sure the next release, I think we're going to do it on the next release, make it public available with all the pieces for the ID, SCSI, Horizon, RAM disk. And it's just a good tool to go out there and start looking and try to understand. If you want to do assembly language programming, I mean, it is a work of art to see what was accomplished back there that people had never thought of doing back in the time.
Without everybody's contribution, sir.
Barry, he thanks you, Barry, and he says, also I aim to support running MDOS binary as is. Lee Stewart comments that we lost the audio. Is that, John?
Yeah, the change the source.
Do we have it back now?
Yeah,
Okay, it's back.
Okay, all right. Any questions from here, or?
What was that card that hooked up to the HFDC to relay the hard
Can you
drive?
repeat the question too, because I can't hear it?
Okay, the question is what was the device that was plugged to the
MyArc HFDC. I've got it here. It's right here if you want to look at it later. But it's called the DREM, D-R-E-M. And the website is drem.info, I-N-F-O. I worked with Alexander. He's up out of Canada for the development of this to get it to work with the controller chip for the HFDC. He spent a considerable amount of time and effort getting it to work. And I think he acquired somehow or another a foray with an HFDC system so he could understand some things there as well. And we swapped log files back and forth there for months, trying to get everything worked out. And at one point in time, the HFDC access, the hard drive access to the floppy was perfect. Then he made some updates to make things a little bit faster. And somewhere in that process, the floppy capability disappeared. And I know Jim's got a DRIM.
I've got two of them.
Okay. And I know I've got 2 DRIMs. I don't know if you've ever connected yours up or using them.
I have yet to have a chance to connect mine up.
Okay. I'm not sure of anybody else in the community that has a DRIM.
Did Chris Schneider get one of them? I thought he did.
I'm not 100% sure. He may, actually come to think of it, I think you're right. I think he did. And I think I cautioned him just about the floppy capability on it at the time. But there's very limited, so I haven't pushed going back to the floppy, trying to get the floppy part of it addressed. And he's actually went on and got the next release of that DRIM. I think it's version 3 now instead of version.
Does physical floppy still work with the HFDC? The DRIM?
The physical floppies will, if you plug floppies into the HFDC, you can still use them and not be part of the DRIM. Yeah.
Okay.
Yeah. It's actually a separate floppy connector on the DRIM board.
Yep.
That you have to plug your floppy cable into the DRIM board the same way you would plug it into a regular floppy drive. If you're not plugged into that part of the DRIM, it's not working.
All right. I
Yeah.
still trip across double density disks, and my HFDC is the only way I have of reading it. I don't always have the HFDC hooked up. I bought about 20 MFM drives at a fair some year ago. I had this grand idea of setting up a bunch of MFM drives.
Okay. Now when are you coming across double density floppy disk, the actual floppy disk, or are you coming across the images like a .dsk image?
The 5-inch disc.
Okay. All right. I was gonna say, if you're coming across just double-sided, double-density DSK images, then what I would suggest is going with the TIPI route, using the program like TI-99. Are you familiar with it?
Yeah.
Okay. Using it to read that DSK image. To my hard drive, and then when the TIPI came out, now suddenly I had the ability to get them to the TIPI, and at that point in time, MDOS did not support the TIPI, so I had to go into GPL mode with DM2K and what they call ROM page mode, where you're actually truly accessing the TIPI as the card, not using MDOS all of there, and I was actually able to transfer files and stuff back and forth in that manner. But now it's, I mean, if you're grabbing files off the internet, the TIPI is the easiest way to go, and like Arcade Shopper there has TIPIs, and I mean, you can get a fully expanded TIPI/Pi for maybe $140 there. And the DRIM, I think, runs about $250. So if you were going to look to do something, I mean, I got the DRIM at the time when the TIPI wasn't available there, but I would really push people toward going with the TIPI and Pi. I mean, just because it opens up exchanging files and stuff a lot easier than what's previously existed.
Yeah. The DRIM is a really good solution if you already have an HFDC.
Yeah. Yeah, if you don't have an HFDC, then it's not. Now, the DRIM's supposed to support 128 megabyte drives. However, MyArc used one of the addressing lines differently, so you're capped at 64 megs unless you make a hardware modification to the HFDC, and then you can use 128 megabytes. But, and that fix was actually posted in Micropendium, I think by Barry Boone back years ago. But if you go, but it's in the DRIM manual for the hardware fix. It's just like a one wire, I think, modification. But I'm not going to change it. I don't need 128 megs on my DRIM. But Any other questions?
No, just a lot of comments that they're very impressed. And I am as well. I don't use my, I've got two Genevs. I don't use them, but I use the TI. And somebody wants to buy a Geneve.
I knew we might find somebody here. So,
Anywhere it was gonna be here.
yeah. So without, I'm going to turn this back over to you, Hal, then. I'm going to turn off his microphone.
Okay, yeah. What? So, thank you very much, Barry. I think everybody appreciates that very much. I know that a lot of people who are watching at home were impressed because we have a lot of comments about it. And I'll be glad to show you the chat in a second. What we're going to do now, it's almost noon here in Evanston, which is pretty much the traditional lunchtime. So what we're going to do is we're going to take a little intermission, and if people want to go and get something to eat, some of our favorite restaurants, unfortunately, are no longer around, but there are still a few left in Evanston. And so what we'll do is we'll take a break while we set up for the next demo and have a little lunchtime as well. So for those of you who are watching us in Europe, maybe you want to go and eat your dinner. In other time zones, it's also a good time to grab a bite to eat. We'll be back, I'll say something like 45 minutes. It's going to be a longer intermission this time than last time. We'll put up a screen that says we'll be right back, and so don't go away. We're keeping the show going, but right now we have to take that intermission for technical reasons. And also we've noticed, we do understand that when we switch from camera to camera, that we sometimes lose the audio. We're trying to correct that. John is making whatever changes he possibly can as we're even now speaking about it. So until the next presentation is ready, we'll say goodbye for now. Don't go away. Don't switch that channel. Are we off? ready?
Uh-oh, we're being summoned.
Yes, go ahead.
We don't have a green room, unfortunately. Well, we have a kind of green room. For everybody's.
Well, it's an amber ring, right?
Yeah,
Him
sort
stand
of
up there.
a yellowish green room. Are we,
I got a green monster on my shirt.
are we ready to roll here? We're rolling? All right, well, we're back live. One of the reasons that we took so long to get back on the air, if you will, is that we had some, are you ready for this? Technical problems. I know what you're thinking. How could that possibly happen at a TI demo? Well, be gentle, be kind. It does. We had, as you can probably see, if you can see the keyboard here, we had a MIDI demo lined up. Vic Stirrup, our president, was going to do that. Unfortunately, it didn't work. So then we switched to Plan B. Plan B was a Polyport demo. Let's see if I can get this up and show it to you. A Polyport demo, and guess what? That didn't work. So we've been trying to correct these problems for the last 45 minutes, and unfortunately we were unable to do so. So rather than have you tune in to watch us fumble about with all of this, we just decided to stay off the air. However, that said, we now move on to our next demo, our next presentation, and our next presenter will be Jim Fessner, who has some interesting things to show us. So I'm just going to call him up here. We're not going to take an intermission. And Jim, if you're ready, come on up and talk to us.
Okay.
And stand right about where I stood.
Yeah. Most of you probably know me, or if you don't, you will soon. I make lots of nice random bits of hardware for our TI system, and for all of those out there who write programs for it, I try to make sure that for those who really need it in physical form, that there will be cartridges of their software available to everyone. Speaking of which, if Joe Morris is out there, yes, your butt plug is really in a physical cartridge. And you will soon find out how weird it will be when one lands on your doorstep. But a couple of years ago, PD did a wonderful version of Turmoil for the TI at the suggestion of one of the folks on Atari Age. It comes out nice. There are a couple of these out there. You can find them on Arcade Shopper's website. Back to Joe Morris in retrospect, Robots of Death. He put this out a couple of years ago. I'd never seen a cartridge of it, so I made some. Karsten, who was online earlier today, here's his Restless 2 cartridge. I love playing this one. And I actually love the idea that Karsten makes sure that all of his cartridges fit into 8K and are playable on a plain console with no other hardware necessary at all. That's his design ethic, and I love it. Last but not least, out of this batch, the most prolific guy out there, Rasmus. I made a couple of copies of his Tix cartridge, of his Tix program as a cartridge, just because. This is one of my favorite games of all time on the TI, and even before that, because I actually bought a PC copy of this game years ago. And the reason I bought it was so that I could translate it to the TI, because I wanted it on the TI. Rasmus beat me to it, and he did a fantastic job doing that. For glitches on the way to the fair, this week I actually took the entire week off so I could build stuff for the fair. I finished a dozen Sam's cards for all of those of you out there using Realms of Antiquity, needing to have a Sam's card to play the game. And when I put all of my 74 LS612 memory mapper chips that make that card work into the cards, all of them had the same bug. So I have 12 cards sitting at home right now with no memory mapper chips. But the last little fun bit for the day, this was brought up earlier today. Some of you have heard about the new Horizon card. This is what they look like. This one is built out to 8 megabytes. Right now here in the US, I sell this card for $185 plus shipping. That's the best price I can get for it because I got a really good deal on the memory chips. When those chips run out, it'll actually have to go up because I got them for about half of what I could get them for anywhere. So, these cards work good, they're solid. Doug Warren, Tim Tesh, and I worked to make sure that the card, the software, and the manuals all match up and are as solid as a rock. So, that's pretty much all I have except for anyone who has questions.
Well, Eric Olson asked what his Rasmus game titles were, and I think Greg McGill answered the question online, but you might answer it for the viewers at home who aren't.
Okay, well, Rasmus started out with Titanium, Road Hunter. On a whim, he programmed Flappy Bird, literally overnight, because someone asked for it one night and he put it up on the website the next day. So that was really nice and quick. We have a whole bunch of ZX Spectrum conversions. Specifically, let's see, which ones are they?
Did you break out?
Breakout is by Karsten.
Oh,
Pajama Rama was one. Saber Wolf is one. Flying Shark is another. You also have, I've got it pictured in my head and now my brain is dead.
The isometric game.
Yeah, that's the one that's in my head. Something lore.
No, not.
Hippie's Nightmare?
No.
Titanium, Road Hunter, Flappy Bird, ZX.
Jet Set Willie, yeah. Bouncy. Saber Wolf, his sports game. Skyway, Tix, and he's also done Dungeons of Asgard, which is a sort of a demo at this point. He's also done a Super Mario clone, which is also a demo. Yeah, there are.
Jabarama.
Pajama-rama, we mentioned that one.
Flying Shark.
Yeah.
Night Lore.
Night Lord, that's the one I was looking for.
Kippy's
Yes.
Nightmare. Is that?
Kippy's Nightmare's not one of his.
Oh, okay.
Skyway?
Eric asked if that might be.
Skyway.
Skyway, we mentioned that.
You've also been asked.
Bouncy's Obstacle Course is another one we haven't mentioned.
Super Mario Brothers.
Yeah, mentioned that.
You've also been asked if there's any update on the SID cards.
As I said, I took a week off to build things. I still haven't finished building the SID cards. I've got a dozen of those sitting, waiting for chip installation and test as well. Because I got myself enough SID chips to test cards. But as I said, when I put those out into the wild, the set of test chips I've got, those are all of my chips. So I'm not going to part with those. You'll have to get your own SID chip from wherever.
Can you explain what that would do for you?
For those of you who like doing sound, there is a very large library of music that was created for the Commodore 64. I think it's about 8,000 titles. And by installing that SID card, you can play all of those. If you compose anything new, and there's not a composer program for the TI at this point, But if you ended up composing anything new, either on the Commodore side and then porting it over, or on one of the online emulators and porting it over, that would also be playable on your TI. I've also seen a couple of attempts to try to integrate some of that music into software people have written on the TI side, just for playing background music. But the SID card itself is a little bit processor intensive because you're sending everything straight to the card. It's not buffering it. So you don't have a lot of options there. Really short stuff works, longer stuff no, unless the computer's not doing anything else. Yes?
I have a question. Are you using the 5-volt variant of the SID chip, or are you using the
Can you
actual?
repeat the question, Jim?
Oh. Are you actually using the?
Jim can repeat the question. You asked him, he'll repeat it.
You're confusing me because we're
Yep.
both Jim.
Yes, Jim and Jim.
Jim.
Yes, the 5-volt variant of the SID chip, or are you using the actual?
I'm using the board itself
Yeah.
will take the 6580
Uh-huh.
or this, what's the other one, 6581
81.
for 668,
6581.
6581 or 6850. 6580.
8580.
8580, yeah. It'll take either one of those chips. All you do is switch the jumpers.
Okay.
And there's a socket for each one, again, so you don't mix them up. So far, every test we've done with every single SID substitute chip hasn't come out right. It doesn't recognize, the chip itself is looking to be in a Commodore, and it's not getting the answers back that it wants.
Yeah.
So it's not actually initializing. And I've got several.
Some of the modern re-implementations
Right.
seem to be very specific to the 6510 bus.
Yeah, and I'm going to keep testing any new variants that I find out there, and if I ever find one that does work fully, I will make sure I publish that information immediately. But at this point, we'll find a way to make it work. Then I will also publish that data, but at the moment, none of those work. You've got to use an original chip.
Jim?
Yes.
You mentioned about the Horizon Ramdisk 4000. Now, it reminds me of Geneve, so I think mine's a little bit different than your default. I get a little more. Does that supply the 32K memory? Or maybe even the Phoenix mod? Or can you say
Okay.
something?
For those, I was asked some more about the Horizon. The 4000B includes the option to insert 2 chips and pull out your 32K card from your computer. If you don't insert those 2 chips and then you put in something like a SAMS, the 2 still operate nicely together. Same thing with a regular 32K card, as long as those 2 chips are not in place. But if you have space issues and you only want 32K and you don't need something like SAMS or any other large expand memory capability, you have the ability to put that onto your Horizon, and it works right out of the box. We were asked about the Phoenix mod for the Geneve users. For those using a Geneve using an older version of MDOS, yes. This has the necessary jumpers so you can set it in Phoenix mode so that you can actually boot those older versions of MDOS the same way you did with older versions of the Horizon. That capability was not pulled away. The card also has what's called a split mode, where half of the card is working as one Horizon and half of the card is working as a different Horizon. Why would that be useful? You could put a second 154 on the board and a second layer of RAM chips, switch into split mode, and effectively put 2 8-meg boards onto one card. We haven't tested it that way yet, but hardware-wise, it looks like it's going to work the way it's supposed to, because everything else is already set up that way and has been since the Horizon 3000 mode to do this half board split, and we didn't change any of that circuitry.
So the chips would just be piggyback.
You piggyback the chips and run flying wires to the 154. And there's actually a row of solder points at the 154, so you don't have to have any pieces hanging out into the sky other than the one pin you're connecting to on the chip, memory-wise, and the other end of the wire connects right into that position on the board. I tried to make it as easy as possible when I updated the board. And I was very glad that I caught Bud Mills at the time that I did to ask him his permission to make more of them. Because that was literally the last person outside of his family that he talked to while he was in the hospital. Do I have any other questions?
There are no questions online at the moment, so Jim, thank you.
Thank you, everybody.
I found that very interesting. I have one of the original SAM cars that I think Jim Critch sold me years ago at the Lima fest that we had in Brook Park. And I've had a lot of fun with it over the years. Our next presenter is going to be Norm Rocky. And Norm, are you going to stand up and talk, or do you need some time to prepare?
Well, I need to get my computer.
Okay, so we'll take another very short intermission, and we'll be back in just a few minutes with Norm Rocky.
And as promised, we're back again. Our next presenter would be Norm Rocky, I believe, who's going to talk to us a little bit about the creative process, if I'm not mistaken. Take it away, Norm.
Okay, well, I'm sure many of you know me as a person that writes TI programs and extended basic that are puzzle programs.
So I'd like to speak a little bit today about what goes into, what are put into the process to get the final product out. And I concentrate on speeding things up by use of assembly language embedded in the programs. And there are two things I speed up. First of all is the definition of redefined characters, and more importantly, the second aspect is the display of the characters on the screen, which is much faster in assembly. So in terms of starting out with a new program, the first step is to define the new characters that I need. And I have a tool that I sometimes use for that, and I'll bring that in a little bit later. But once I get the characters redefined, I write a short, extended basic program doing all those character redefinitions in extended basic. And then I make use of a program that came from Barry Traver. He published something called the Genial Traveler, which he called a discazine. It was like a magazine, but it was disk files, some of which were program files, others were DV80 files, which you could load into TI Writer or Funnel Web and then print them out if you decided to do so. And he put out a program called Fontals. And this was an extended basic program in merge format so that I could load that program that I had defined the new characters in, and it was in merge format so I could merge it in, and then at some point in my program where I had defined all the characters that I wanted to redefine, I could link to a subprogram, and that was called Fontals, and then it would lead me through, ask me which characters I wanted to redefine. It could be arranged from here to here, and I ran that, and that gave me a DV80 file, which is an assembly language source program that would do the definitions for me. That's fairly straightforward, no big deal about that. It didn't probably make much difference in the speed, but it was somewhat faster. Now, part of the reason for doing this in extended basic initially, I'm not a touch typist. And so as I type programs in, I make errors. And sometimes these show up in various places. And so if I do it in extended basic, it's much easier to catch the errors that I may make and correct them to get what I really need. So that's part of the reason for doing it this way, rather than just going directly to assembly and defining things. Now, to the next step, which is getting the screen display. And perhaps before I go any further, for some of you who may not be familiar, I do my programming in the Classic 99 emulator, and let's see if I can. I know the program I'm looking for is in one of two disks, and I want to no, I think it's 6.
You have a space issue there.
What? Oh, no space between old. Let's see, function. Yeah, F2. There. And now I need a D there, and then I can.
Take your word for it, I didn't type it.
What?
I was being impertinent, sorry.
I'm demonstrating my problems with typing, yes. If you didn't believe me before, you believe me now. That was not necessarily planned, but it worked out well. So, okay, I got the right file. And so the program that let's see, what I want to do now is run this. And just for those of you who may not be familiar, I think I may have displayed this a while back. But these are some mazes that were created by a woman who lives in the UK named Andrea Gilbert, and she has a website where these are available to you. And I got her permission to implement these in Extended Basic, and they're available to anyone, no charge. That was part of what she was concerned about. And here's my information. And I don't think I'll go through the directions. I'll just go to the menu, and you can see that there are 14 different mazes or puzzles. And let's just go to the first one. It's very straightforward. I don't think I need to go through the operation of this, but you can see on the screen the display that I am going to need to implement in Extended Basic or in assembly language. And so now, for each of the 14 mazes, I had to write an Extended Basic program. I could load in the character redefinitions that I got from Fontals for each one of those. So I had 14 programs. Each of those, I had to use those definitions and create this display on the screen. Okay? Now, I did this because based on Barry Traver's example, I said, I can write a program that will do the same thing for screen display. I can write it so if I display it in Extended Basic, I can merge in my program, call it, and it will then generate the assembly code for displaying that puzzle on the screen. Okay? A lot of work, but still, that's the process.
Is the purpose for the red ball to intersect the blue square?
It's supposed to move and wind up where the blue square is located.
Okay,
Yes,
right.
yes. And it can move, and if you make one move, then the next move has to be in a perpendicular direction. Okay? And I may as well mention it now also. When I first displayed this over in the European meeting back in, I guess it was 2017, which was in Rome, I believe, someone said, could you display the minimum number of moves or the actual number of moves that you were making? And I hadn't done that. And after that, I did do some thought for it. And my initial thought was I was going to have to move each of these displays over to make some space. I went back about maybe a year ago and read the assembly or the editor, the Extended Basic book about call or the display at, because I knew the basics of that, but not all the in-depth stuff. And it turned out that I could place some information in this area of the screen. If you can, I'm sure that, do you have a pointer that I could use?
Your mouse.
What?
Your mouse.
Oh. Oh, okay, yeah. So over in this area, I could display some data. And what I will display is the minimum number, as far as I know it. I don't know it for an absolute fact, but I'm pretty certain of it. And then that will be beside the letter M, the minimum. I'll also put a letter A, and there I will print or display a running total of the number of moves that you have made. Okay? That's in the process, and that will be coming, and as soon as I have that worked out, I'll send it to the TI Game Shelf, and I'll also send it to the Ciro Barilla Italian Users Group website. He has it up there also. So that's the That's the purpose of everything I'm doing here. Now, as I said, I had to write 14 extended basic programs, each of which would display one of these puzzle screens. And let's see, I'll go down. I think this is what I want, yes. And this is a photograph that I took of the printout of that particular code, and I think I somehow can expand this, but I'm not sure how I did that. Maybe it was just, okay, that's better. So you may be able to make out the code here. This is one of the largest, actually the very largest, of which there are 5 different ones. And these, the way I implemented it, required 21 rows of 21 characters to display. Okay? Now that's a lot of characters. That's a lot of information to keep in memory. And it appeared to me, and there were 5 of these. So there are 5 that are this size. It's 441 characters taking up memory space. And it appeared to me that it might be a good idea to see if I could condense this a little bit and get it done in a little bit smaller amount. Now, each cell within the maze, I don't know what the proper term for this is, but is defined by 2 characters basically. And so, well, 2 characters on each of 2 different rows. And it appeared to me that there should be some sort of reproduction, some of those arrangements of characters that should be in different places. There should not be unique. There should be a lot of duplication. And so you may be able to see the little pencil marks that are between some of these data points.
Yeah, I think a magnification button at the top in the middle there that you can blow that up.
Let's see, where is...
That's above the black bar to the left, your left.
I'm sorry, I'm not...
A little bit higher. That one to your left.
Oh, okay, yeah. Then.
Click on that.
Oh, there we go. I knew I'd tried this before, but I didn't. Is that better?
Yeah.
Okay, some of it's missing, but the point is I was thinking that there had to be some grouping of 4 characters that might be duplicated throughout these various puzzles. And so I went through each printout and I drew lines between these 4 characters on each row. In terms of the assembly language, this information would be fed into a VMBW command, video multiple byte write, to transfer the data from ordinary memory to the VDP RAM, and then it gets displayed on the screen. And so I went through each of those 14 different printouts, copied down these sequences of 4 bytes for 4 characters, and I'm sure at some point during this process, which is a very labor-intensive process, tedious process, I must have thought, what did I get myself into? And do I really have to keep going on this? But I did. And so I conceived of these sequences of 4 characters. I term them bricks because they're long and oblong, and it's like building something with a stack of bricks, but building it from the top down, which sort of interferes with the analogy. And So I got this data. Now, how was I going to find out which things were unique? Next step was to take these collections written on paper and type them into an Excel spreadsheet, which is another labor-intensive process. And I got everything entered into and then I sorted it so it would sort out things so I can identify things that were unique. And I wound up with 74 different patterns that came up as unique and were what were involved in defining all of the screen displays. And so the next step then was to implement that, and let's see, I got the when I was in Rome, David Kane from the English Users Group asked me if I could write an article for him to put into their yearly newsletter. And I wrote an article about this step of the process, and there we go. And went down too far. But I wrote a little sample program just to test whether my concept was correct. But so this is not the actual data, but this is just some test data so I could check to see if things were working right. So here I have 1, 2, 3, 4, 5, 6 bricks. And so the first one is 4 capital A's and 4 capital B's, 4 capital C's, 4 capital D's, 4 capital E's, 4 capital F's. Okay? That's what would be printed out on the screen if this thing worked properly. And so, and BRKS, that's bricks. This is where the bricks are defined. These are the various structures possible. Now, I am going to use the video multiple byte write to print these on the screen. Video multiple byte write requires 3 bits of information in 3 separate registers. Register 0 requires the address or the location on the screen where this will be printed. Register 1 requires the address in memory where this data to be transferred is located, and that will come from this list of bricks, okay? And so where oh, okay. Okay, down here I load register 1 with this location where the start of all these definitions is located. Okay? Now, the next step is I have to, here is the list of offsets. This is data point 0, or 0, 1, 2, and 3 are the first 4 characters for brick 1. And so if I want brick 1, I have a value of 0. That will keep me at the location BRKS and will transfer 4 characters from that position. If I want the second brick, which is the 4 capital B's, that starts at position 4 with respect to the address BRKS and includes characters 4, 5, 6, and 7. So there's and so this list tells me first I want to print the first brick, then the second. The next one is at 8, that's the third. The next one is at 12 or OC. Next one is at 16 and 20. So I have a list here of which of these I should use in which particular order. And so within this, I'm doing a loop and actually a double loop. And when I get one loop controls how many bricks I place on the screen, and the other was how many rows do I go down before I'm done, basically, and not to get too deeply involved in this. But this is a Microsoft Word copy of the program that or the article I gave to David Kane. If anyone would like this, copy of this, I can pass around a sheet of paper, and you can give me your email address, and so if there's any interest, that's available. And let's see, I'll close this out. And now what I'm going to, now what is next? Okay. Now, I didn't do this at the time, but in preparation for this meeting, I decided to sort of get an idea of how much did I condense things, or how much space did I save by doing this. And so there's a file called stats here. And this is just an Excel file. And the first column is the size of the mazes. Is the size 5, 6, 7, 8, 9, or 10. The number of characters necessary to display that, for the 5, it's 11 by 11. For the 6, 13 by 13. You notice that it goes up. It's an odd number of rows and columns from the numbers from 11 to 21. Now the next column is how many total characters that is for one puzzle of this size. So 11 squared is 121, 169, and so on and so on. Okay? The next column is how many puzzles of that size are there in the whole 14 complex. So there's one of size 5, 2 of size 6, 3 for 7, 1 for 8, 2 for 9, and a grand total of 5 for the largest one, 10. So multiplying the number of puzzles times this character total, I get another total, and that's how many total characters, and if you add it all up, there's 4,350 characters or 4,350 bytes of data necessary to be put into this program that have to then be put on the screen using this method. Well, not using this method. If I had done it the original way, where I just printed everything as individual characters with all those repetitive patterns. Okay? Now, it gets a little bit complicated here, and let's see. Okay. I determined that there were 74 different bricks, in quotes, each one 4 characters. So that's 296 characters or 296 bytes. Now, all of these numbers for how many characters on a row are odd numbers. None of them is an even multiple of 4. So how did I handle this? Well, for the for 11, 15, and 19, those are 1 short of a multiple of 4. So I just, the simplest thing is to print a number of bricks that's a multiple of 4, and I'm printing an extra one over on the right-hand side, and generally that will be a space character. I didn't see a more convenient way of avoiding that, and so that's how I did it. Okay? So the number necessary for those is included in this 296 that just deals with the bricks. Now for the other sizes, for 6, 8, and 10, that's a number which is 1 more than a multiple of 4. 13, 17, 21. In that case, I had to print an extra column of characters down the right-hand side And so for the size 6, there were 2 of those. Each one required 13 additional characters, which is 26. For the 8, there was 1 of them. It required 17 different characters. And the 10 size 10 character, the 5 size 10 puzzles or mazes required 21 additional characters printed down the right-hand side for a grand total of 105. And the total of those is 143, and adding in the 439. I don't have the number there, I guess. I thought I had that somehow. Where can I? No, there it is. I don't know what happened to it. 439. Okay? 439 characters to display this on the screen. But there's another thing that takes up memory, and I don't have this on the screen, but as I mentioned for that trial program where I gave you the list of this is a byte that tells me the offset for the first brick, and that's a list of bytes that is necessary to accomplish the actual display. And I did I don't have the information here, but for the size 10, there were 5 rows of, what is it? Oh, there were 21 rows, and each one had 5 bricks. So that's 105 per puzzle. So 525 bytes of data were needed to make that list to tell what's the sequence of bricks needed to print out one of those puzzles, or all 5 of those puzzles. And it took 190 for the size 9, 68 for the size 8, 180 for the size 7, 78 for the size 6, 33 for the size 5. Okay? The grand total of all that is 1,074 to store the data for how to get to the right brick to print in a particular position. So 1,074 plus 439, I have that number here. That is 1,513 let's see, 1,513 additional bytes of data necessary to get the job done. And that plus the 436, no, I'm sorry, 1,513. And I added the 439 twice, I forgot it. So it's somewhat less than a half as much data as if I had done it the original way. But it was a considerable savings. Okay?
Norm?
Yeah.
How many unique characters each puzzle? I mean, I don't think there's that many.
What?
How many unique characters in the puzzle?
Well, it differs depending on the size, but I found 74 unique patterns of 4 characters amongst all 14 of the puzzles.
Seems it should be less than that, but I'll take your word for it.
Well, part of it is complicated by the fact in some cases I was including that space that's outside the puzzle. Okay? And I just sort of intuitively thought that this approach was something that would be more efficient, take up less memory, and allow the program to load faster and all those good things. Okay? Now, I mentioned that the puzzles require an odd number of characters, and I mentioned that I use two characters on one row, and right below it basically designs a space within the maze where that ball can be at any given time. Now, why does it take an odd number when 2 is an even number and it's multiplied by any number, okay? And I couldn't quite think of how to describe this, and what is it not letting? Is it, I'm sorry, it's asking, no, I've already saved it, so, okay. Now, where am I? Okay. I came up with a method to sort of explain this, and my starting point for this was, okay, if you start with a checkerboard and turn it into a maze, what would that look like? And that sounds rather bizarre. In this explanation, we don't need to take account of the fact that on a real checkerboard, the alternating squares are different colors. We don't care about this, but this is another article nope, I'm out of order, just bear with me here. Kung Fu Maze 2, and that may raise some questions, but we can deal with that if. Now, this again is an Excel program, and I designed this sheet so that the squares are approximately square, and they probably are not exactly, but close enough for my purposes. And when I find a maze or something else which has a maze-like structure, I like to print out a copy of this, and then I draw the walls in red ink at the proper locations and any other information I need to implement it. And I apologize for the people that are watching at home or elsewhere, but I'll pass this around if you want to take a look at this as I describe what I came up with. Now, I'm not sure what the proper term within the maze generating or creating community is. There may be a term, but I will refer to some. This is a cell, and it's an Excel, so it's actually a cell within Excel. But within a maze, there are these same sort of square units that are stacked side by side and on top of one another. And so this particular cell, which I've highlighted, would be at the top of the maze, and so there should be a wall on the top of that cell, and there should be a wall at the left edge of that cell, right? Makes sense. What about the right edge and the bottom? Before we deal with that, let's move to this cell. It's at the top, so there should be a wall there, right? Obviously. What about the left edge? It depends on which maze I'm dealing with. There may be a wall there, there may not be a wall there. But if there is a wall there, then there is also a wall on the right edge of this cell. So I don't need to deal with that twice. I will just deal with it here. If it's there, and it's automatically on the right side of the first cell, okay? Correspondingly, if we move, I don't want to do that. If we move down to this cell, below the first one we considered, it's on the left edge, so there's a wall there. Is there a wall at the top edge? Maybe, maybe not. But if there is, then there's a wall at the bottom of this first cell. So throughout this whole array of cells, I only have to consider, is there wall on the top edge or on the left edge or both? Okay? That was just a eureka type of moment. And now, let's just say it's a 5 by 5, so where am I? There's the 5th cell, that's the 5th letter. Okay, so there is at the top edge, maybe not on the left edge, but now on the right edge, we don't have another cell, but we still need to deal with that position, and so let's call this cell 5A. And all we need there is, definitely there will be a wall on that edge, so that's, now I am going to describe this space or define this space by 2 characters, 2 characters, 2 characters, 2 characters, 2 characters, and then I need this extra 1 character regardless of the size, okay? So the size of the puzzle in my implementation is 2 times the size plus 1. That's the total number of characters. So that's where that comes from. It's not necessarily intuitively obvious, and it wasn't obviously to me what the actual reason was, even though I knew how to design it without that knowledge. Now, with that information in mind, now it's time to go to a second article that I wrote for David. He's appreciative of this because if he gets somebody else to write an article, that's a page or 2 or 3 or 4 that he doesn't have to deal with himself, and all he does is do the, well, I'll show you what he, so, wrong choice.
Yeah, Norman, for those that weren't able to see the paper there, when you start with what you're passing around, laying down, sit there. First of all, it's just a bunch of numbers there first.
But now what I can do is look at that sheet, and I can look at this cell within the maze, and is the top edge of that cell a wall, and is the left edge. And so I can design a character of 4 characters that I can describe that, so I can look at the picture that I've drawn, sketched out on that sheet, and then design that, and so I don't have to go through all this work of finding unique, different structures. I can design the structure automatically, and so that simplifies things immensely.
Yeah, it becomes a lot more obvious with the sheet
Yeah. And one of the things that may not be obvious on there, well, let's get this, let's get my there we go. This is what now here is maybe I had it right the first time. Let's scroll down through this and yes, okay, so what David did, he put the title in, okay, so not a whole lot of work. He's done this so much that that's really straightforward for him. He positioned any photographs or stuff like that that I sent him. But what so basically 1 character, wall at the top and on the left, wall at the top, wall on the left, and then some places internally there will be or in any of the 2 of these at the top, 1 at the bottom. So if I had these 2 at the top and then this right below this, that would define a certain cell structure that I could, and one of them would be a blank space, okay? And so I can now look at this sketch that I have copied onto the Kung Fu Maze Excel sheet and just come up with the appropriate characters and design what I call a block. It's a block rather than a brick. And I can design this, and I can say, this block goes here, this block goes here, this block goes, much more simple, okay? So, now, where's my, and let's see. Now, that obvious, our printing blocks is a different animal, but I haven't written the code yet, but I should be able to do that. Now, the last thing I want to do I told you about the fact that I wanted to put the minimum and actual moves onto the tilt maze. Andrea also, I just started looking at this recently. She wrote some 3D tilt mazes. And I said, that looks interesting. And I started saying, well, let's see how this might be implemented. And in her implementation, she had the top layer or the upper layer displayed, and then there's a facility within the puzzle to drop down to a lower layer, if there is one, or if you're at a lower layer, to lift up to a higher layer. But at any point using the app on her website, you only saw one layer. And I said, if I implement this, I want to have over by the side in a smaller version what's on each of these 3 layers, because I personally cannot keep track of where I might be on another layer, just having seen it briefly. And so I started doing this, and let's see if I can type this. I gave this a memorable name so I wouldn't forget what it is. Tilt Chicago 21. And let's see if this loads, and now let's run it. Oop. I guess that didn't do any permanent damage. So this is what I came up with, and I pretty much used a lot of what I learned and just talked about in terms of designing a block and implementing it. But these are the 3 different levels: upper level, middle level, and lower level. And the place where there's a D, that's a place, if you reach that position in the maze, if you choose, you can drop down to the corresponding level in the maze below it. So if you move to here and drop down, then you would be here in this maze, and that would display on the screen to show you where you actually were. And it looks very complex, and I haven't figured out any of these mazes working it on her website, and I don't know if I will succeed in doing so if I implement this, but that's where I am at the moment.
You could have possibly a hidden layer.
What?
You could possibly have a hidden matrix with numbers indicating inclination, which
Well, what I hope to do is as you move the ball in the larger version, that I would have a smaller version of the ball winding up at the same place.
Right. But you figured out how to represent the inclination in the maze?
Well, it's a tilt maze, so you tilt it one way or the other.
And how do you represent that?
Just like in the one-dimensional or the two-dimensional tilt mazes, you move left, right, up, or down. Although the orientations are different in this, in that it is north, south, east, and west. And so if you want to tilt it to the right, that would be to the east. If you want it to the left, it would be the west. North would be up, south is down.
I see on the horizontal right there, looking at that, I'm trying to picture that block. Is that 3 layers front to back?
Well, we're looking at the top.
You're looking at the top?
Top down. Top down.
Okay, all right. I guess.
Left and D is drop. So
D and L, D is drop. On the top layer, all you can go is down. So drop will drop you down. So if you are at this position, well, let's see.
Okay, I guess one piece I'm missing is why isn't there 5 levels there then? So that you.
No, there are only 3 levels. This is the entire top level, the entire middle level, the entire lower level.
So it's 3 by 5?
No, each of the mazes is 5 by 5.
It's a stack.
But there's
three stacks.
it's like take 3
stories
boxes and
tall.
stack them one on top of
Okay, all right.
another. Each one's an individual maze, but you have to.
And so-
one, get to the right.
And,
place on the
and so
Okay.
if you move to this position in this larger maze over on the left side here, which would be displayed, if you move to this, then you had the option of dropping from that to this maze in the same location, which would be here. Then you would be in this maze at this position, then you could move around in this maze, but confined by this oddly shaped area. Yes.
If you want to have more fun, you should also implement inertia.
You only have Ds and Ls in certain positions, like your top floor, you've got Ds, but you don't have a corresponding L in the middle floor. Does that mean you can only go up from certain spots?
Yeah, that's the way Andrea designed it, so I'm just implementing what she designed, and so.
D is not like an open hole. When you drop down, you can lift back up through it. You gotta go somewhere else.
Yeah, yeah.
Okay,
Okay,
I was
yeah,
confused
yeah.
when I first.
Yeah, it's,
If you look, there are places where there are Ds that go from the first level to the second level, and then there's this corresponding D at that same location to drop you down to the third level.
Yeah.
So there are a couple of where you can.
oh,
jump.
the other thing that it's not obvious, well, there are 4 different mazes, each with 3 levels like this. This is just the first one, okay? Now, in all cases, the ball starts in this. Ball starts in this
Top left.
up here, and it must get to here. They're all the same. They all start at the top level, and you have to get to the opposite corner on the top level by hook or by crook. Now, I designed this just using what I last described and shown on that sheet I passed around. This is top and left walls. Top wall, left top, 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 and then this extra character over here is left. Okay, and similarly, and I started out by just designing that as an empty 5x5 square in extended basic commands. And then I went in and found out, yeah, certain places I needed to change that and add walls or whatever that weren't, and so I filled in the rest of, I had to define 4 more characters with a D built, one with a wall on top on the left and a D, one with a wall at the top and a D, one with a wall on the left and a D, and one in an empty square with a D. And I had to miniaturize the D a little bit so that it didn't bump up against the walls of the maze, okay? And the same with the L's. Now, how am I going to implement the full size, okay? That becomes somewhat of a problem.
Will we see that 2022, the 40th?
What?
I say, will we see that next year?
Now let's look at something else. I mentioned there was a tool that I used to some extent, not exclusively for designing my characters, but this is something called Grapefruit. I don't know who created this, where I got this from, it's a long time ago, but this allows you to design characters, okay? And I've used this, and let me load in a file here and open an image, and I need to scroll down here. Now I can't remember what I called this. I thought oh, TI-99. I knew I did something reasonable with it and memorable. Turned out not to be quite so memorable. But let's open this. Okay? Now, some people might say no effort was spared. I spared a lot of effort here. Now, for the tilt mazes that I showed you earlier, this is the set of characters that I used, or representative of them. I moved everything down to the left, to the right, and lower. And if you look at this character, there are 4 different quadrants, and I only used the quadrant on the lower right. And so I have a part of the definition of the wall at the top and part of the wall at the left. So now let's go down. This is directly below this. That's a complete character from top to bottom. This row of characters is in the 5th column, and 5th column is something that has sort of a bad connotation. And so hopefully my mentioning it doesn't get any notice from the federal government. And you're in this meeting with me, so you'll be, so I'm in good company. And so if I go down even further, again, this would be at the very bottom of the maze, and this could be, let me see, this could be just, in some places there would be another cell below this, and I would need this character, but this gives you the idea. But oops, well, let's go back and look at this. Now, here, this is a complete character, okay? And what I did in the tilt mazes, I designed it this way so that I could point to this particular character on the screen and then use a call gchar. Is that right? Yeah, call gchar, and check what was beside it to see whether I could move right or left or up or down. Okay? If there was a space, and let's go over to the character here. This is a space character. There's nothing there. So there's no wall. If there's no wall there, that means I can move 16 pixels to the right. Okay? And so I had a reference point where in initializing the maze, I pinpointed this is the row and column where that character that's directly below the ball is located. And so I could check one character to the right. If it's not a wall, I can move 16 pixel positions to the right. Then check the character 3 spaces over to the right. If that's a wall, you're done. If it's a space, you can keep on going. I figured out how many times I could find a space moving by 2s over to the right, and then multiply by that by 16, and then slowly change the location of the sprite by 1 pixel. And I had the pixel row and column. That was also part of the initialization, so I could change that to move it from one side to the other, or up or down. So, and I just, various ways I could check that. I could say, check that character, and if it's less than 117, then it's not a space. And then it is a space. I could, any number less than 30 or less than 33 or less I could use for that comparison. But that's the purpose for that. Now, let's say that I want to do that with the 3D mazes, okay? I can still do the same design sort of thing, but it's a little bit different, but I can still design 4 characters, 2 and 2 below, that have the top and the left, whether they are walls or not. And there are more different structures that I can come up with, but I can still go directly from my diagram from the Excel spreadsheet to a representation that will do that with the characters that I'm working with. Okay? So I no longer have to do that program and transfer it into what you saw on that very first sheet where I scratched things off, blocked them off, and did all the entry into the Excel spreadsheet, which is a much better place to be, in my opinion, for this. Okay? Now, the reason for doing this in this program is that then those D's and L's, I can actually put that into that character space to represent where those points are within the maze at any level. Okay? Now, for the smaller representation, I'm using one implementation. For the other, I'm using another. I'm running into a position where I'm having difficulty being able to find ways of redefining characters to bring everything together. Okay? As far as I am concerned at this point, I can use this implementation. I can define the magnification for that ball is magnification 3, so it takes 4 characters to define it. Okay? And so I have to take 4 characters from what I have left. I have 1 character set left remaining, and I can design that large ball, and I can design it in any color I want because I can specify the color of the sprite as anything I want. And so I'm going to design it in a character set which is transparent and dark blue. But I can define the sprite as blue in its definition. It just takes a pattern from that definition. That will allow me to design one of the remaining 4 characters in that group as a single character that will represent the final location position within the larger maze, and I can design another one which will design and define it in the smaller representation. But I have nothing to design a smaller red ball in the smaller representation. And so that's my conundrum at this point. And yes?
And that's using all the character sets that are available to you in Extended Basic, correct?
Yes. Unless I can figure out some way to do a whole lot of character redefinition so I can get some other character set of 8 characters that I transfer their definitions to something else, some of the lowercase letters that are less necessary. I have some work to do.
Could you also just switch to RXB and use the extra character sets from TI Basic? That'll give you 4 more sets.
Are you doing this in straight Extended Basic?
Yes.
Yeah, because TI Basic has some extra character sets that you can deal with,
But no sprites.
but RXB lets you have the sprites and those extra character sets.
Okay.
Extended Basic.
Okay.
So that's the both worlds in this sense.
Yeah, again, I have some things. What I can't do is have the smaller ball move in conjunction with the other, because that would require a, well, I could if I, again, figure out a way to get a whole new character set in Extended Basic, that I could move things out of there that I might need in their original definition, but make it in red and transparent. And then I could just take 4 characters and just make a small red square and the rest empty, and so I could just position that. And I have my work cut out.
Mag 3, it's only 1 character.
What?
If you're not going with Mag 3 on the sprite,
I can't do one sprite in Mag 3 and the other in Mag 1.
Okay, because you call it.
If I use Mag 3, I have to do that for all sprites as far as I know.
Okay.
And that's my understanding of, you choose a magnification and that's it.
Could have your small sprite be just like 1 pixel.
Well, I could use magnification 3, but just to find one of the characters, and the other just be, but again, I'd have to find a whole bunch of characters that I can duplicate in some other location, and so I'm at a place where I wasn't expecting to be, but I'm here.
But that's what I said. Look at RXB. It may give you a way out of your ball.
I will do that.
You're using
Yes,
a
it
TI
is.
system with the 9918 processor? Or with the video, it's the 9918?
It's just well, I'm using the emulator.
Can you use the emulator with the 9938?
I have no idea.
Well, what I'm thinking then is if you would use it with 9938, Alexander Holmview had written some assembly routines that can be used with extended basic. And then what I was thinking was that maybe you might be able to step up, and instead of using characters, using you define your blocks on a video screen, and then you copy a 16 pixel by 16 pixel block to your screen. That way you can have 192 separate patterns. But with a 256 by 192, I think it works out. You can create like 192 to 100. I think that works out to 192 patterns. It wouldn't run on a 99.4a, but if you get to the 99.38 there, you can step up
Yeah.
to the video commands there, copy pixels instead of redefining characters itself. But
Yeah.
display that on a screen in Extended Basic.
Yeah, the other thing is that when I get done with my programs, I use another tool from Genial Traveler that allows me to embed the assembly into the saved Extended Basic program.
You probably wouldn't be able to use that.
Yeah, that's another, there's, well, that's where I am.
Okay.
Any questions from the audience?
Just one question from Francisco Uda in Italy, and he wanted to know.
It. So if you would like a copy of it, I might be able to get that to you.
Okay.
Just give me your email address and what you want.
Okay.
Norm?
Yeah.
We've lost the audio. Okay, let me,
Right.
Mike in here.
The mic.
Mike needed the mic.
Lost the audio for some reason. Just the last second or so. I don't know if the battery died in here or. No, the camera went off the number. Camera went off? Oh, okay.
Let's
We have a video and audio problems. Okay. Want to turn the camera on and I'll take a look at thank you very much, Norm. I enjoyed that, and I hope people at home did. I know everybody in the room did here as well. What we're going to do now is we're going to take another very short intermission while Waleed Malouzi sets up his demo. He's got a very interesting demo coming up. So please stay tuned, and we'll be right back. Hopefully. God willing, and the TI guy. After that, then we break, and let me make a couple announcements that don't need to go out on the air. A, if you've got a car parked in the garage downstairs, it closes at 6. If you want to leave it there until noon tomorrow, you don't have to do anything, but you won't be able to get your car back until noon tomorrow. Number 2, this rapacious city charges a couple bucks an hour to park. So if you're somewhere and you have a car parked in a parking space, they do in fact come around and ticket, and you have to pay until 9 o'clock at night, which is outrageous, I think, and I'm a taxpayer here. But everybody gets raped in this town for money, for anything. Property taxes, I don't even want to discuss. I don't want to think about it. The second thing is, right across the street is where we're going to have the banquet, and we're going to have the banquet. I told the guy originally at 5:30, we are a little short on demos today. We had some technical problems. We had a couple of videos that were promised that weren't delivered, so we're running a little early. What we can do is, when we're done cleaning up, we can go across the street as a group and eat early, and then even start the pub crawl, the infamous pub crawl, early. I don't know how early, if that appeals to anybody, early. Usually we do it totally after the meeting when it's dark, nobody can see us. Or we can, we have some presentations to make. We have some door prizes to give away. We have, you know, the usual thing at the banquet every year. Most of you guys have been there before. You know how this goes. But usually we are there starting at about 5:30. We usually go down to Panera. Panera is now closed, so we can't do that. We're going to go across the street, as I said. So there is free parking in Evanston. And if you do get a ticket and you don't live in Evanston, especially if you're out of town, take your ticket home as a souvenir of having made it to the fair. Don't worry about paying it. They're not going to chase you down. They'll chase me down, but they won't chase you guys down. I live here, damn it. All right. Our next presenter is going to be Waleed, and we're going to go back on the air. I'm going to introduce him. I'm going to sit down, and then afterwards I'm going to speak for about 2 minutes, just thank the people who came, et cetera, et cetera, et cetera. Thank the library, you know, on and on. But that's about it for me for right now. John, when you're ready, give me the thumbs up, and we're ready to go.
We're going to do a group photo after.
Second?
We're going to do a group photo.
Yes, we can do a group photo. As soon as we get done, we can get somebody to take a picture for us.
We're all going to wear masks.
The thing about the group photo is it will show that we're not as many as we normally are, so we probably won't publish it. We'll send it out to anybody who requests a copy of it. But we won't put it on the
Facebook.
Facebook, because everybody will say, "Oh God, look, there's nobody here. The family's dead." I don't want that. So if you want a picture, take one. But we won't make a big deal. We're a small group. This is a Mike. Don't go away. We want you here for the picture. We want you here to watch this demo.
Do I have to?
Come on, sit down.
You're one of
Grab
us.
a chair. We got plenty of chairs. We got tons and tons of chairs. We got chairs over here if you want one.
Yeah, we got spares over there.
You got a chair there? All right. How long will your video be? You can have as much time as you want.
10, 15 minutes.
Okay, 10, 15 minutes? That's fine. All right, John, are we ready to start up? We're already going? Yeah. Well, thanks a lot for telling me that.
He did give you the thumbs up.
He gave me the thumbs up. I'm going to give him...
But my mask says all.
Yes, another thumb. Well, anyway. We're back for our sins. And we have one more demo that we'd like to do. We're running a little short this year. As you probably heard me already say, we don't have as many presentations as we'd hoped to have this year. Next year, our 40th Faire is going to be a much bigger event. We are going to have dancing girls and people riding elephants and musicians playing 76 trombones, etc., etc. It's going to be a major thing. You have to come next year. God knows if there isn't a world war or a worse plague than COVID-19, we hope to see everybody here. So that's it for me for right now. Waleed, take it away.
Thanks, Hal.
Do you need to move camera?
As most of you know, I'm really...
Wait a minute, we don't have you mic'd up.
Oh,
Sorry. My fault. Okay.
That's the cabling, but not the connection.
I got carried away with nostalgia. And now I'm going to be carried away by the people who are screaming right now. We can't hear me. Wait a minute, let me put it on. I've had all my shots.
Is this on? Can you hear me, John?
Yeah? Okay. So, this is a demo of my current project. It's not complete by any means, but I figured we may as well show some of it at this gathering. So I'm a big fan of the old 70s and 80s games by the company called International Team. It's an Italian company that produced these fantastic games which you see on the screen here. And these games were mostly strategic war games. And the major characteristic of the games, first, they were made beautifully, and they were big. I mean, each of these games in real size is that tall and that wide. These things are big. And when you went to a game store in the 80s, and they stood out. They were usually lined up on the back walls, and they were expensive. I couldn't afford them at the time. I got one as a present when I graduated. So I own several of them now, and one of them in particular interested me, which is this one called Kroll and Prumney, which is a science fiction game. I am a science fiction fan, and and the game is not too complex, so I figured it might be possible to recreate it without too much difficulty on the TI. So this is the actual box of the game, and this is huge, beautiful game. And the inside of the box is counters, and this is a map. It's a map that becomes that big. It's several cardboard pieces that fit together like a puzzle. And the game essentially consists of two warring factions in the very distant future, which are competing for colonization of the planets. There are a few issues with this, and that is the space is filled with these obstacles, which are meteorite fields, or asteroid fields, I should say. And also, each game turn switches on and off what they call temporal disjunction, where only a certain color of asteroids shows up, and the others disappear. They're still there, but they're in a different dimension. And if you happen to be at a place where they reappear, your ship is destroyed. And all these circles here are the planets. So I thought long and hard, how am I going to do this? And I decided to do it using a Tippy mouse. I had recently acquired a Tippy, and you've heard a lot about the Tippy today. And the outstanding feature of that device is that it has a mouse, a standard USB mouse, which can be accessed by the TI through a driver that Matthew Splett wrote, similar to the Mechatronic mouse of old. And here is a representation of the map on the TI. This is a huge map. It essentially consists of 4 full screens on the TI arranged in a rectangle. You have 1, 2, 3, and 4 screens. And another issue I considered with the TI is that it's still a big game. The map is big, the game is relatively complex still, and I only have 24K in extended basic. I wanted to do this in extended basic. I felt that for artificial intelligence and computer algorithm design, it's easiest to do it in a high-level language. And I figured extended basic was definitely something I wanted to do. Plus, I wanted to have it run on a stock TI with just 32K of RAM and a disk drive, nothing else. Even the TIPI would not be required, which means that you could play this game either with a mouse or with just a plain keyboard. I would not recommend playing it with a keyboard alone. It's too slow, but it works. The mouse is much more intuitive. So I'm going to go ahead and load what I have right now. It's only half done at this point. There's no AI, there's no enemies yet, but I'll show you how the interface looks, at least, to give you an idea where we are at. So I'm going to switch to the TI screen here. Okay. And this is running off the TIPI on the drive of the TIPI. So first we get a introductory screen, and we'll just load. Now I am using here XB 2.8 Gem by Harry Wilhelm, which is a special XB. And the only reason I'm using it, I'm not using any of its features. The only thing I'm using in it is its loader. It uses the the assembly language loader that's in the minimum cartridge rather than the extended basic loader. And it's about 10 times faster to load assembly language with it than it is with a standard XB cartridge. This game is a hybrid assembly language and extended basic. There is no way I could fit everything in 24K, but we have this 8K, beautiful 8K of memory, which is unused by XB, but is totally usable by assembly language, which I could use to stuff into it the graphic elements of the game, and also all sorts of routines to access the screen and to create windows and things like that. And so there's a large section of the game that is resident in 8K of RAM, in low memory we call it, that's pure assembly. And then the rest is in high-level extended basic for the game logic primarily. So I think it's an ideal situation for the extended basic programmer to get the speed and the flexibility of assembly, while at the same time having the ability to use a higher level programming language for most of the rest of the game. So let's make sure. Okay, the mouse is not working. Oh, never mind. So first we have to use the keyboard. Okay, so now I have the main screen. We have only one set of asteroids on here. We have two other sets that are not visible currently. We have a cursor which we can move around. Okay. As you can see, it's rather slow. Alternatively, if I press Control M, I can activate the mouse, and now okay, I don't know what happened. Let's do it again. This has never happened before, by the way. All right, we'll load it again.
How did you create that graphic screen there?
Well, I'll show you in a second.
Okay.
After we're done with the quick demo here, I'll show you what that looks like. I use Magellan, basically. Are you familiar with Magellan? It's basically this PC graphics program created by, I believe it was the Codex, and then enhanced by Erasmus. And it basically allows you to design screens as big as you want. And it you also define characters, and then you can see exactly how they're going to look on the TI. All right, let's try again. Okay, so mouse is on. So now, as you can see, I can move anywhere. I can scroll the screen. okay, with the mouse. I can move from one screen to the other by pressing 1, 2, 3, or 4 keys. This is back to the start. We have some random stars. We have the asteroid belt. We have here the launch bases for your units. So the first thing you want to do, you have several units. You have colonizer ships, which are transport ships. You have cruisers, which are basically attack ships. You have fighters, and you have mobile bases, which help protect your launch areas and also repair your ships. So first thing you want to do with the game is you want to launch or place your mobile bases. So you click on the screen, on the initial screen. So now we have 2 mobile bases. You're only allowed 2. Then now you're ready to launch your units. If you click on these units, for example, you get an information screen. And it gives you a direction of movement, damage, missiles, and movement potential, and several options. Now, these mobile bases do not go into hyperspace. I'll talk about hyperspace in a second, but they do move, and they can fire if there's something to fire on. More about that in a second. So to add regular units, I just click on one of the launch bases and then pick either a cruiser, a transport, or a fighter. So example, say if I want a fighter. Fighters come in 3 always. So there we are, we have 3 fighters. Say I want to move one of them. I just click on that. And it gives me its basic info. And then I can go to move. And now I have its movement potential. I can go back, and when I'm done, I click quit. So I just click next to it where I want it to go next. Okay. If I want to, I make a mistake, I want to go back, I can take it as much back as I want, and then move in another direction. Then when I'm done, just press Q, and we're done. Another thing is, let's pick another unit here. Oh, this unit, okay, so we've got proximity to the fighter unit. So let's go to this one here. Okay, and let's say we want a cruiser. Cruisers and transports can only move in one set direction, and you get to change the direction only at the end of the next turn. So we have to select a selection, so I'm gonna go with 2, which is a diagonal. And now if I select that unit, it's on direction 2. Now, if I can take it into hyperspace. You can take any unit except fighters and mobile bases into hyperspace, and then at any point later in the game, bring them back anywhere on the map, with the caveat that once they exit hyperspace, they cannot attack, nor can they move for that turn. So they're sitting ducks. So that's good, because you don't want to be reappearing in the middle of enemy units and start shooting away at leisure. And so let's say you want to take it into hyperspace. It needs to have its movement potential of squares ahead of it in the direction of movement, completely free to be able to go into hyperspace. Otherwise, it would be blocked. So let's say it's going to go into hyperspace. Oh, I didn't go into hyperspace. Let's try again. Okay, it checks, and then it sends it. That noise you heard is just a placeholder sound. Old CS1 on Atari Age has actually created a beautiful sound for hyperspace, which I haven't had a chance yet to incorporate. That'll be in the final game. Say you want to have it reappear. Now we have a unit in hyperspace, right? So let's click on an empty space, and now we have hyperspace unit. We have a cruiser, which is here. So we just select that cruiser, and it'll appear where we want it. And now if I select its unit, you notice that now it's got 0 movement, 0 missiles, because it just exited and it cannot do anything but sit for the next turn. And that's basically where we are at this point with this game. It's essentially done with the user interface. The problem I've had is that incorporating all these functions can be done purely with the keyboard. No need for a mouse. It's obviously slower to move around the map, but you can do it. but it doubles the amount of memory I need because all the code has to be duplicated both for keyboard and for mouse, and they're two different processes. The workflow is a little different. So I still have about 9 kilobytes left of main upper memory for extended basic. So I'm a bit concerned that may not be enough for the artificial intelligence and the opponent. We'll see. If I get really, really tight, I may have to take the keyboard option out completely and just stick with the mouse. The issue with that, then that limits the game to only people who have tippies. I was hoping ideally to have it available to anybody, whether you have a tippy or not, you can still play the game fully with just 32K of RAM. We'll see how it goes. Yeah.
Could you have your loader load one of two different versions of the game, one that's keyboard only and one that's mouse only?
You could.
Put it on the same disk and then just select it at startup.
That's a good option. It's definitely doable that way too.
Another possible option, since you said you are going to be using that lower 8K memory space, if you put a SAMS card in there, you can put the main 8K lower memory as a trampoline to routines elsewhere in the SAMS, and then you have a whole lot more available storage space for stuff you're not using right now.
Right. But it adds an additional component to the game, which means people need to have now a SAMS card instead of a tippy or both. So I'm trying to keep the equipment count as low as possible.
Understood.
It's an option too. I like actually Vic's idea too. I mean, it's definitely something
I definitely like Vic's idea.
because then it keeps the options open for both. I would hate to eliminate the keyboard option. It's as slow as a keyboard, and I feel that the keyboard is a little bit more flexible. The joystick works too, but again, I'm trying to minimize equipment stuck to the machine, and so yeah, that's where we are at. And I'm going to put a plug here quick as to what I used to develop this so far. Nope. It's something called TI-coded, which Steve B on Atari Age developed recently. I don't know if you guys have heard of Tidbit by Matthew Haggerty. This is basically a TI Basic, Extended Basic translator where you write your programs without program lines, and you can have them structured any way you want, and it'll translate it to a standard Extended Basic. Now, what Steve B has done is he's expanded this a lot further, and he created something called TI-coded or TI Code Editor. And I'll open the file for Kroll and Prumny here. And let me just plug this in. Okay. So we're into the code editor here. As you can see, there are no program lines. It's all structured. You can indent things. But he also added a lot of things like control loops using, for example, while loops or repeat loops. He also included a case statement. Case allows you to select different options for variables. Say, for example, case k equal 1, 2, 3, 4. For each option, you can have a block of code for that variable value, which saves a lot of code and makes it a lot clearer. For example, let's go down and I'll show you one block here. Here. And you can see here, this is a case statement. Let me raise it up a little bit. Where UID is the variable and I have different values of it, and I can assign blocks of code to each one. But he goes further and he includes also begin and end block statements where you can have a begin and then a whole slew of statements in there and then an end. And you can include those in if then else statements. So you can have unlimited size of code in an if statement without being able to and build the project. And once it's built, you can actually run it straight from Classic 99. The extended basic code that's produced is here. As you can see, it's ugly as heck, but it works. Nobody really wants to work with this. You'd much rather work with something like that. He also includes a log. If there are any errors, it tells you how much memory you've used so far, which is really handy. He also includes a character and sprite designer, which is really nifty, all in the same program, and you can animate the sprites too. And finally, he lists all the variables in your program and the associated program lines. This is invaluable for debugging. And you can also, and it also writes directly to a file in a directory in Classic 99, so your output goes to Classic 99 and can just run it immediately. So there's no intermediary, no compiling, nothing. It's really seamless, works really great, and frankly, without this, your work is doubled or tripled easily. So yeah, and lastly, just to show you, this is the assembly language stuff that the routines associated with the program. This is all sitting in 8K, and this is the font here, and then this is all the map here. And what the routines do is basically, it's a static map initially, and then the routines simply update that block of memory on the fly as I change things, as ships appear, ships disappear, the phase of the game, etc. It's all updated on the fly and like that in assembly. It's very quick. It's seamless. So it creates the windows and everything. So it's really ideal for working in XB and streamlining the process. That's it. Any questions?
I'm sorry, I missed the name of that software program?
You mean TI coded?
What's that?
TI coded.
Yeah, cool.
Yeah. There's a whole thread on Atari Age for this.
Is your lower 8K already full at this point?
I'm not sure. I don't think so. I still have a bit of space. These assembly routines are really very, very economical in memory use. The biggest chunk is really the map. I could have compressed that, but it would slow things down to compress it, decompress it on the fly. So I chose to keep it as is. If I run into trouble, I'll change that. But I don't have too many things left to put in there, so I think I'm going to be okay. Anybody online has any questions?
Well, let's see. Rich Gilbertson laughed that the camera was on when I didn't know it. Then he mentioned when it wouldn't load the first time. The new loader doesn't do that often. I think it does not initialize XB correctly. And then he said, this is why the second attempt always works.
Well, I mean, it's good to know.
Yeah, I guess that's pretty common. Well, anybody else have any comments? Any questions from the peanut gallery?
All right. Well, thank you all.
You have to remember howdy doody, the peanut gallery.
So I'm hoping to have this.
You don't know anything.
I'm hoping to have it ready by Christmas, hopefully. Well, we'll see. Yeah. Yeah, it's there's only the AI to do, and so hopefully we'll get that done. All right, thanks, guys.
Thank you, Wally.
Yeah.
Okay, I will unmic you before you get up. And
Well, here you do it.
yeah. Yeah. Whatever this it is. And I have to turn this off. We only have the one battery.
We're done, right?
Yeah. I'm surprised it lasted this long, actually. It's 2 years old. Before we go, there's a few people I'd like to thank. First of all, I'd like to thank everybody that showed up today. I really appreciate the fact that people took the time, spent the money to get here. I want to thank all of our presenters, Waleed, Norm, Barry, Vic, who tried to present and couldn't because of technical problems. I also want to thank the people at the library who set up the tables, Ray, who's brand new at this, Todd, who showed him how to do it. I want to thank
Dwayne, who brought his family, who's a first-time visitor here. I want to thank Mike Nicholson from the Windy City group, who has a lot of gear that he'd love to pass along to people. I want to thank everybody that came. And I would like to hope that next year we will see a lot more of our friends, especially all our friends from Europe who have made the trip before and maybe haven't made the trip but would like to come and hopefully will come. Many people have expressed interest in coming to the fair over the years and haven't been able to make the trip. I'm hoping the next year, since it's the big 4-0, they will make it. And also I'd like to thank my wife, who's been sitting over here all afternoon. She's not on camera and I don't think she wants to be. She's been helping people sign in. And our technical director here, John Shanafield, who has brought most of this equipment in, carried in all the TI equipment, carried in all his own stuff, set up all this stuff, is over there sitting behind several different screens. When I first started in television more than 50 years ago, I was working at a station that had exactly one camera. This is a 4-camera show now. Got 1 camera on the screen, 3 cameras on the presenters and on the keyboard. You've seen, as we flash between different screens, you've seen some of the cameras, maybe not all of them. At any rate, I'd also like to give a special thanks to all those who have contributed by paying their dues or just making a contribution. That is what keeps this show going. That's what keeps the fair going, because we have certain expenses. We have to rent this room, for instance, without that, we would probably long ago run out of money. So thank you all the gentlemen and ladies and whomever has contributed. That's about it from us for this year. It's a little shorter show, as you can see, than usual. We do still have our monthly show, and we'll be bringing that to you. And now the good news is, on YouTube, about this time they always ask you to subscribe and hit the bell and share and all. Please share this with your friends. You don't have to hit the bell and you don't have to subscribe, because we're only on once a year on this channel. So if anybody has anything they'd like to add, I'd be more than happy to listen. And if not, we're going to say sayonara, goodbye, bonsoir, and guten Abend, and everything else to everybody. And we'll swing the camera around and take a look at some of the people who are here. Everybody wave, please. Wave at the group. There's Caesar way in the back. There's my wife over behind the screen, waving over the top of the screen. Wally's behind the camera as usual, way over in the corner in the dark. He likes to sit over in the dark, I think.
Doesn't matter, I know already.
Yeah. So there's John, and there's some of his equipment behind him. Got all kinds of stuff. And, we, again, haven't got as many people here as we'd like to have, but we certainly will hopefully have a lot more next year. So John, this time if you can tell me when we're off the air, I'd appreciate it. And goodbye from here, goodbye from Evanston. We'll see you all next year, hopefully.